Thanks for watching this video. I'm Jenny Friedenreich. Let's get started. In trigonometry, right triangles are important, but 90-degree triangles are special. We can figure out the side lengths of special right triangles if we were given one side. You can create your own 90-degree triangle. It's super easy. I'll show you how. Start with a square. I'm drawing one that's 4 inches on each side. Then cut the square on the diagonal, and I'm going to do that here. The two triangles created are congruent. Each 90-degree angle is cut in half on the diagonal, and half of 90 degrees is 45 degrees. And that's how you get a 90-degree triangle. The longest side is called the hypotenuse, and it's opposite the 90-degree angle. Now let's look at the relationship between the hypotenuse and the shorter two sides called legs. If the hypotenuse is C and each of the legs is A, we can use the Pythagorean theorem to find the relationship we'll use in all problems. Recall that a squared plus b squared equals c squared. In a 90-degree triangle, both legs are A. Combine the like terms, square root both sides, separate the root over multiplication, and now we have the relationship. The hypotenuse is square root of 2 times the shorter side. Let's do some examples, and we use this relationship discovered without going back and doing the Pythagorean theorem all over again. First, check that you're given a 90-degree triangle. Note that you're also given one side length as a value, 7. Let's use the template to find the two missing sides. Notice I'm not going to use the Pythagorean theorem. I use the template. The template has a different orientation from example 1, but just identify the hypotenuse and the legs, then match them to template. Each leg has the same length. Looks like 7 is a leg because it's opposite a 45-degree angle. That means our missing leg has length 7. So the hypotenuse is just the square root of 2 times 7. And let's mark that. Looks like we found the missing sides and we're done with this problem. Example 2. In this problem, we again check that we are given a 90-degree triangle. The side marked 24 is opposite the 90-degree angle. Let's look at the template. Again, the example triangle is not positioned the same way as template. No worries, just match the side length by what angles they are opposite. In template, the hypotenuse is a root 2. In example 2, the hypotenuse is 24. So we match these two up and we write an equation. So I'll write a root 2 equals 24. We want to find the lengths of the legs. That means we want to find the value a. Divide both sides by the square root of 2. And as we do this, we notice that this leads to something that's a lot cleaner than a fraction division problem. And the 2 cancels with the 24, we get 12, so we get 12 root 2. And that's what I mean by it's a little cleaner than 24 divided by the square root of 2. So what we just found was the legs. In example 2, what we're looking for is the legs. So we just mark the legs as 12 root 2, and we've solved the problem. Looks like we're done with example 2. In both example 1 and example 2, we use the equation hypotenuse equals square root 2 times the leg. In summary, examples 1 and 2 show you how to find a leg or how to find the hypotenuse of a 90-degree triangle. If the value shown is opposite the 45-degree angle, you are given a leg. Your job will be to find the hypotenuse. You just take the value given and multiply by the square root of 2. If the value shown is opposite the 90-degree angle, you're given the hypotenuse. Take the value given and set it equal to a root 2. Solve for a by dividing by the square root of 2, rationalize the denominator. That gives you the value of both legs, and then you're finished. Thanks for watching. Please subscribe to my YouTube channel for more great math videos.